Anyways, sorry, the video is not playing. I showed you earlier, the picture needs to look like this to be able to fit in a rocket that we have. And then once it's released from the rocket, it needs to go through multiple deployments of the mirror, the sun shield, the telescope, and so on to be able to work together. So a whole bunch of technologies are needed to make this happen. James Webb is now ready to go. It's being put together and getting ready for launch, hopefully next year. In the 2010 decadal survey, they focused on cosmology, try to understand dark energy and dark matter. And so W1st is being designed right now. This is what's going to be looking like, but the technology requirements for W1st are, again, it should be in infrared, but it needs to have a big field of view, and I don't know if the video will play again here or not. Unfortunately, the video is not letting me play. So we are.
Mansoor Saab, you have a few minutes left.
Okay, so I'm almost done then. So the next one is, so now we are preparing for the 2020 decadal survey. And in order to help the scientists figure out what to focus on, we have actually spent the last 5, 6 years coming up with the 3 or 4 different big mission ideas as to what kind of missions we can build and what kind of science we will do. And we have offered that to the science community, and now we're waiting for their deliberation. These are some of the large missions that are being considered for the decade survey for 2020, plus about 10 probe-sized missions. And in 2021 is when we will hear back from the science community to let us know which of these 4 that they think we should be moving forward to. So we are thinking that the next focus would be really to find life in around other stars. And to be able to do that, we really need larger and larger telescopes. So we feel that we will even need much bigger telescopes than even James Webb. But we have to wait and see. This is the current set of observatories that are actually in space doing all kinds of astrophysics. Some of them are being developed, some are in flight already. And so the 2020 decadal will speak, and hopefully it'll take another 10, 15 years to build the observatory that they think we need to build. So again, there's opportunity for all of you guys to be part of that. And so maybe in the rest of this conference, you will hear more about astrophysics and cosmology, and maybe it will get your juices flowing on how to help NASA build some of these observatories to answer some of those questions. That's all my presentation, and thank you very much for your attention. How do I exit from sharing?
Thanks, Khalid.
Thank you, Mansoor Saab.
Okay.
Any questions?
No, if there are any questions from the students, they can ask us by writing them on the meetings page. So one question for one of the student, Shamak, is that how much time does it take for a spaceship to be launched from Earth to space station? So he's kind of asking the time it needs for the launch to reach the space station.
So space station is very close by. It's 250 miles above the Earth. So given all the orbit dynamics and mechanics and making use of the gravitational forces of the Earth, it only takes a couple of days to launch from Earth and reach the space station. Maybe even less.
So any more questions from students? So one is that, is there any collaboration between NASA and CERN? Because CERN is also working on dark matter.
Though there is no direct connection between NASA and CERN. CERN again is the ground-based physics, whereas NASA is space-based. So CERN is more collaborating more with the National Science Foundation within the US rather than NASA.
One of the students is asking, why is Mars considered better than the moon for being habitable?
Um, it's not better in a sense, but I think the idea in the end is to be able to to be able to live away from Earth, and Mars is very, very similar to Earth as compared to Moon. So understanding Mars has other reasons because we understand Mars at one time had atmosphere. It has had flowing water on its surface. So we also need to understand what happened to the atmosphere, what happened to water. So hopefully that will give us a clue as to what may happen to Earth, and therefore we can avoid that from happening. So the journey is not just to go somewhere, but eventually to be able to go deeper into space, maybe go into interstellar space travel over maybe over the next 1,000 years or so. So we need to make our targets bigger. We've been to moon already, and so the bigger objective really is to go beyond moon and into deeper space.
So, if no more further questions, then we thank the speaker. Masood Saab, thank you very much for this interesting talk. And I'm quite hopeful that we will have you in NCP again in Islamabad. Thank you, sir.
Thank you very much for asking me. I really enjoy these talks, and I definitely hope to see you guys in person next year.
Thank you. Thank
Okay,
you.
Khuda Hafiz.
Okay.
Thank you.
Good afternoon.